Hello and welcome back. Today I'll be going over a simple physics simulator in MIT App Inventor, and we'll be simulating the motion of a projectile, in this case a ball, inside of a vacuum, meaning that there will be no friction or air resistance to consider. Before I go into the code itself, let's look at the simulation first. We enter our initial velocity and the angle we're firing our ball at. In this case, I'll pick 20 meters per second and a 45-degree angle. When I press this launch button, you can see how the ball would move in a vacuum if launched at that angle and velocity. Now, let's look at the code. Since we're trying to represent a ball moving in real time, we'll be using the clock component, along with a variable to track how much time has passed. I'm going to have the clock run every 16 milliseconds, and I'll have the variable for time increase by 0.016 each time the clock runs. Every time the clock runs, I'm also going to update the position of the ball so that we can simulate the ball's motion in the air. To do this, we'll be using the physics principles associated with 2D motion. When the program starts, we ask the user to input two things, an initial velocity and an angle to fire the ball at. We can split this initial velocity into two components, the x velocity and the y velocity, with the help of trigonometry. The x velocity represents the velocity of the ball at a given time in the x direction. As per Newton's first law, an object in motion stays in motion unless acted upon by an unbalanced force. Since we don't have to worry about friction or air resistance, we can simply say that our x velocity stays constant, since there is no unbalanced force acting on the ball while it's in motion. Velocity represents the speed of the object and its direction, so if we have our x velocity in meters per second, then multiplying it by the current time gives us its current displacement. This means that in order to find out what we should set our x position to, we just have to set it to the x velocity multiplied by time. Now, onto the y velocity. In this case, we do have another force acting in the y direction, being gravity, accelerating our ball downwards at 9.81 meters per second squared. To find out the vertical displacement of our ball at a given time, we can use the formula VIT plus 1 over 2 AT squared, where VI represents our initial y velocity, A represents gravity, and T represents our current time. Now, we have to make sure we don't just set our y position equal to the displacement from our equation. In MIT App Inventor, a y position of 0 correlates to the top of the screen. If we want to accurately reflect our ball's displacement, we should subtract our displacement from a starting point. In this case, we're starting from the top of the cannon, which is at a y position of 140, so we should do 140 minus our result from the equation to get our y position. And that's all we have to do. Every second, the ball's position is updated on screen around 60 times, which allows us to see the ball move through the air a bit clearer. By the way, you might be wondering why I'm multiplying my x and y displacements by 7. I'm simply doing this so that the actual movement of the ball can be seen clearly, as a pixel is quite small. If you have any questions, let me know in the comment section below. Otherwise, goodbye.